Good day, everyone. Today I will explain the construction of minimal DFA from the regular expression. So this is the given regular expression: open parentheses 0 plus 1, close parentheses, open parentheses 0, 1 plus 1, close parentheses times 0. So, or mathematically written like this. So first I will explain the meaning of the regular expression. So basically, the expression open parentheses 0 plus 1 close parentheses means the string must begin with either 0 or 1. Next, the expression open parentheses 0, 1 plus 1 close parentheses means 0 or more repetitions of either 0, 1, or 1. Lastly, the final 0 means every accepted string must end with 0. Therefore, the language generated by this regular expression contains strings that start with 0 or 1, follow the pattern of repeating 0, 1, or 1 any number of times, and always ends with 0. Examples of accepted strings are these: 0, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0. Examples of rejected strings are 0, 1, 1, 1, 1, 0, 1. So now I will discuss the epsilon NFA construction. So I created 4 states named Q0, Q1, Q2, and Q3, where Q0 is the starting state and Q3 is the accepting state. So from Q0, both inputs 0 and 1 go to Q1. So at Q1, there is a loop labeled 1 because the expression allows repeated ones. And there's also a transition from Q1 to Q2 labeled 0 and Q2 back to Q1 labeled 1. This represents the pattern 0, 1. And then finally, there is a transition from Q1 to Q3 labeled 0, which represents the ending 0 of the regular expression. So this is the epsilon NFA diagram that I created. And then I converted the epsilon NFA into DFA. So the DFA contains 4 states named A, B, C, and X. A is the starting state, C is the accepting state, and X is the dead state. So the transitions are: from A, inputs 0 and 1 both go to B, and from B, inputs 0 go to C, and then 1 loops back to B. From C, both inputs 0 and 1 go to the dead state X, and then the dead state X loops to itself on both 0 and 1. So this is the DFA diagram that I made. Now I will explain the minimization process. So the DFA is already minimal because no 2 states are equivalent. The accepting state cannot be merged with non-accepting states, and the dead state loops itself for all inputs, and the dead state behaves differently because it loops forever on every input. And then the remaining states also have different transitions and behaviors. So there is no further minimization possible. And then in conclusion, the minimal DFA for the regular expression open parentheses 0 plus 1 close parentheses 0 open parentheses 0 1 plus 1 close parentheses star 0 recognizes the language generated by the regular expression. Thank you so much.